Thank you, David. Welcome, everybody. Yeah, Ian Rosam from Bentley Systems, Director of Product Management for Civil Infrastructure here. Now, I'm based down in the south, out of the Horsham office, if anybody's familiar with that. Yeah, subject in hand, it's a hot topic. It's popping up everywhere, and the term AI is creeping in everywhere. So I really wanted to do a little bit of an introduction in terms of perceptions of AI, because I think that's sort of an interesting aspect as to where a lot of this is actually stemming from, and really where we get our information. And I say we, as in all of us, as in the we. And sort of I started thinking about this, and there's two sources really that drive us here. There's the sort of the big tech companies, shall we say, and the image that they portray and information they give around sort of AI, but there's the media aspect as well that's leading in with this, whether it's BBC or CNN or whatever sort of news media. And obviously the perception around AI can be very heavily distorted. And so the third aspect to it really is what I like to refer to as Hollywood AI. And most of the time, Hollywood AI is presenting that dystopian future where something goes wrong or machines are taking over or whatever. And it sort of steps over some of the value that actually really AI brings in, because it brings in this dystopian future, as we sort of refer to. But I find it quite interesting that, Hollywood AI, it stems back to some great writers, and actually some favorites of mine, with iRobot. And a little bit of a challenge to anyone that's thinking about this, when Asimov wrote iRobot, back in 1950, which is absolutely astounding. And of course, that introduced anybody that's a bit of into sci-fi, the three laws of robotics started to creep in there. But then another sort of favorite, with Arthur C. Clarke. I would actually say on both of these, the books are far better than the movies. But both of these real visionaries as to value that AI can bring, and yes, potentially a bit of a dystopian future and things going wrong there, but quite visionary in terms of what they were doing. But just a little bit of the history of AI, and just sort of going and sort of searching around and sort of finding some information. So credit here to infodiagram.com in terms of this timeline. I think it was quite interesting. Around the same time as those books were being written, you've got Alan Turing, again, some great movies around with Alan Turing and his work there. But the first chatbot, which we're all familiar with on our phones now, came about in '64. So it's not a new concept that we're dealing with here. Now, to a certain extent, there was I'm going to call it the doldrums. Kind of slowed down a bit. There's obviously progression that was going on there. But the one that makes me laugh is in about 95, I think it was, with Windows 95, Microsoft Clippy. Who remembers that little assistant that was coming up? And that's a key phrase, assistant. Meant to help you. Did it help you? I don't know. It was quite annoying. But anyway, you can see the timeline of things sort of really starting to kick in. And obviously, as we move into the 2000s, it really starts to accelerate. And what we see is accumulation of all of these advances. Now, another way to sort of look at this is from adoption of technology. And again, it presents as quite an interesting sort of overview in terms of the adoption rate. So again, credit here to sort of BI Intelligence in terms of this. But we can see obviously the sheer acceleration of technology in recent years, and the smartphone and adoption rates on smartphone is absolutely incredible. But the one that was astounding to me was this representation here from Demand Sage. So, as I say, lots of information if you just go and Google it. But this is a road to 100 million users. Now, you look at that. I mean, we're probably all on this call using all of that technology, or well, perhaps not Instagram. I'm above the age where I would probably want to use Instagram. But the adoption rates are incredible. And ChatGPT, 2 months to hit 100 million users. Now, that is phenomenal. But why is that the case? Well, it's kind of the perfect storm. It's on the back of the pandemic and everything that we had there, and realistically, it was coming down to resource constraints, changing sort of work practices, We've got an escalation in terms of potentially, or an aging workforce and a retiring workforce. We haven't got the sort of the education system pulling through engineers into the domains, so we've got fewer graduates in the workforce. Changing work modes, working remotely or hybrid, and just whole practices are changing. But at the same time, construction is still ploughing ahead and wanting to achieve greater efficiency in terms of their processes. So this is kind of setting the scene as to really what's going on, and again, more sort of reports that are readily available, but things like Goldman Sachs research, it highlights the AEC industry, where there's a need for AI not to replace people, and this is a key phrase, not to replace people, but complement people and what they do with automation and unlock productivity gains. So that's the key as to what we're trying to achieve, and obviously with large language models and with co-pilots and assistants, this is really where we start to see how can AI really help us in the workplace to address some of the key challenges that we face in the infrastructure sector. So with that, I'd like to hand over to Karl now to put some meat on the bone, shall we say, and explain a little bit more around what we're doing for infrastructure and AI.
All right. Thanks, Ian. If you don't mind, I think I'll just share myself. It will be easier than just asking you to switch the slides. So yeah, just give me 1 second. All right, it's back.
Yep. That's good.
Perfect. Yeah, maybe I just introduce myself quickly before starting to speak. So I'm Karl. I've been with Bentley for a little over 6 years now, and I manage the AI team. Actually, the largest AI group that we have inside Bentley, and we have been working with the civil infrastructure team since 2023. So so I did a bunch of projects in Bentley and now focusing on that civil infrastructure. And one of the reason why we moved to the civil group is because of that generative AI buzz that we've been hearing of over the past years, right? So everyone has, just like ChatGPT had a huge impact. We know we can generate text now with language models. We can also generate images, right? Everyone has seen what Stable Diffusion or DALL-E can do. And when you see that models are getting better and better at creating those realistic images of women walking in rain and all of that, obviously, as engineers, we ask ourselves, okay, could AI also generate designs for road or rail or whatever, right? And it might not be as easy as generating a picture of a woman walking under the rain, but that's one thing that we've been obviously looking at. So what do we think generative AI can do for infrastructure? It can really help with some of the new deliverables that we have with regards to sustainability and resilience. We think it can help us create better design or consider different options that we don't have as engineers at the time of modeling every single option that's possible for a project. We can get better insights by leveraging information from past projects, and then we reduce the risk of repeating mistakes. And overall, we can just deliver more with the workforce that we have, right? Which leads to higher quality of projects. And like Ian said, when we think of machine learning at Bentley, we really see it as a tool that the engineers and the architects will use so that we work together and we increase the output of humans. And at the center of the collaboration between humans and AI is the data, right? And that's really, really important. Machine learning, it's really machines learning, and they learn from data. They don't learn by us giving them classes, right? In university, they learn by looking at data, at a ton of examples, and extracting tendencies and statistics from that. So at Bentley, we have a little bit of data, but most of the data that we have, it's actually our users' data, right? Which is really, really important. I will talk about that a little bit later. But what's also important is that when we apply machine learning, if we apply it, for example, to digital twins, there's a ton of different sources of data in a digital twin, right? That's one of the things that made digital twin powerful is that they bring together data from a lot of different sources, and all of that data, sometimes it's siloed, right? It doesn't necessarily talk to each other. It's in different formats. It's in different applications. And our job at Bentley is really to bring all of that data together so that the insights from all of these sources of data can talk to each other and can give us an overall picture of what's happening with the infrastructure. So whether we're talking of drone surveys with reality data or sensor data from IoT, or design data like schematics or stuff like that. It's really only when we bring all of that data together and we allow AI or machines to learn from all of that data that we can get a comprehensive insight. So it's not only considering data separately, but it's really bringing out an overall picture, and it's informed by the context of the project that we are making. So we don't think that AI can be as successful if it doesn't know the context of the type of projects that you're doing, of where in the world you are. So I'm from Quebec. We have a ton of snow, so creating a road project in Quebec, it's much different than doing it in Florida, right? So you have to be, the AI has to be aware of the context of the project that you are working on and have that information, because otherwise it's going to learn from examples, but not examples that apply to what you are doing. So yeah, like I was saying, context is really critical. So at Bentley, when we are creating a model, we are creating it for a specific domain. That doesn't mean that it won't be applied later to other domains, but we are doing it. We are solving one problem at a time and then reusing what we are doing for other aspects or other domains. But we are doing it always with the idea in mind that AI needs to be aware of the context. So we don't want to apply vanilla ChatGPT to something because we want an AI that knows your domain and that's going to speak the same language as you are. All right, going back to the data, I think this is one aspect where Bentley is really strong and transparent, and it's one of the reasons why I really enjoy working at Bentley, is that we are very responsible with the way we handle our users' data. So these core principles are, they've been first announced at YII 2023, so it's been over a year, and I can basically break it down in three aspects. So the first one is that users have control over their data. So Bentley will never use a customer's data without their consent. It's always, you have to opt in and tell us what you are willing for us to use your data for. So that's the most important thing. You can opt in, you can decide not to opt in. You can opt out at any time. We keep full traceability of all of the data that we use to train our AI models. And if a user is not satisfied with what we're doing, they can decide to walk away. We'll retrain a version of that model without their data, and they'll be done with it, right? And you can decide how you want to contribute your data. So if there are cases where we think we can pull data together from multiple users and provide additional value to everyone, but that's always an option. You can also decide to just have your data be used to train your models and no one else gets the benefit of your data. So it really depends on the context. If we're doing design scenarios, it makes more sense to keep everyone's data siloed so that if there are trade secrets or secret sauces, they don't help your competitors. But in other cases, if we're looking at detecting cracks, for example, on asphalt, there's not a lot of IP there. So we think we can make a better model by pulling data from everyone together. But again, that's something that we will be transparent about, and users have to decide if they're okay with that or not. How are we using AI today? There's a ton of different aspects. You see it with the ads that you get on social media or all of that, but it's really becoming everywhere, right? AI is applying everywhere. In our domain, we can see it for safety measures, for example. We can automatically detect if humans are infringing on security requirements. We can use it also for talent acquisition, and we can use it for a bunch of different aspects. So that's really interesting. Now, I just want to talk about some of the projects that we have done at Bentley, some that we are currently working on. And I want to start with this one, which is one of the first projects that I did when I joined Bentley, and we were looking to extract information from schematics drawings. So in that case, it was for a specific type of drawings, PNID, process and instrumentation diagram. So a big diagram with a lot of pumps and tubes and pipes and valves and all of that. And a lot of our users, they had hundreds or thousands of these drawings in paper format or just vanilla AutoCAD drawing with no semantic information, right? And they were looking to create a digital twin to be able to locate easily a specific pipe if they had the tag for the pipe, and they had to go through a stack of paper, find the right page, and then understand what the pipe was doing if they had to repair it or service it or whatever. So what we did is we created a solution where you can upload your drawings. They can be PDF, PNG, whatever, just raster drawings. Some of them were actually even hand-drawn, right? They weren't even CAD drawings. And we use machine learning to extract all of the information that's present on each of these pages. And then we can import that to an iModel and create a digital twin. And there's always a review phase, right? So machine learning is not perfect. It's extracting a lot of the information. It's finding the tags. This is an example of a hand-drawn one, right? Where we are still extracting most of the stuff. But it needs to be validated by users. So you don't trust 100% the AI. You have to double check that everything is right. We can also help the users validate information by giving it what's the confidence level of the AI. So you can choose to focus your review on everything that the model is less confident about, and everything else you can just bulk approve. So that's the way we did it. And now you get all of that information in a digital twin. What you can also do is import that data in our authoring tool and recreate an intelligent drawing, so that if you have to make edits or changes to that document, instead of recreating it from scratch, which takes a long time and you can introduce error by doing that, you can start from all of the information that the AI has extracted. Again, it's not perfect, it's symbology based. So if you have unique vessels or unique items on your drawing, you will just get a bounding box and you have to recreate that part. But most of the stuff, you're getting it for free, and you're getting it with the semantic information, the dimension of the pipes, the pressure rating of a valve, for example, all of that. So that was pretty cool. We did it for PNID. It's been in production for over 2 years. We have a lot of users who are really happy about this, and we are also thinking that we can expand that to other types of drawings, right? So I've not later than this week, I got a bunch of drawings from a rail company that wanted us to look at how we can apply this technology to extract the information from their drawings. We are also considering doing it for roads, for example. So it's, again, like I said, when we build an AI solution, we are doing it for a specific domain because we need to understand what are the specific rules to that domain, right? So pumps, they have a flow direction, for example. So that's one thing that we are extracting for PNIDs that maybe we don't need to extract for other domains. But when we're looking at doing rail or road, there are other specificities there that we want to be aware of and that we want the model to learn, right? So that's how we are approaching the problem. We're building technology for a specific domain, and then we're applying it to other domains. Another place where we created an AI solution is for construction. So here in Synchro, what we did is constructors have a bunch of photos that they take every day of their infrastructure or how they're building it. And they wanted to have a way to index that. So we know that's fairly easy. It's one of the things that machine learning is better at, is identifying stuff in pictures, right? So now all they have to do is dump all of their pictures, and they will get tags on each of their images, which image show a crane, for example, or traffic cones, or where was that that lift seen the last time, right? So you can just double track. You can backtrack in your pictures and see how your construction site evolve over time. Another place where we are applying image recognition is for inspection. So we do it a lot for roads and for bridges, for dams as well. What we can do is we have AI models that can detect different types of defects, cracks, spalling, exposed rebar, all of that. And when you do a survey with a drone, for example, you can just run the AI tool on the pictures and you get detection for all of the cracks. But then when we recreate the 3D model using iTwin Capture, we can also reproject all of those detection and get in 3D the cracks and the defects that you have on your asset. So by doing that, we also get metric information. So we get the length of cracks, we get also the width of the cracks, and you can also use photo navigation to look at the original pictures so that you can get in full resolution what did the crack look like. So instead of having to send an inspector on site to measure cracks and do a detailed survey, you get that just by flying a drone, and then from the office you can do the detection and you can map how much cracking you have on a bridge, for example, and decide if it's time to do maintenance. We also applied that to rail. Actually, I did a couple of projects on rail where we were detecting different types of defects on rail from picture images. It was with one specific client, so I cannot really show the data. Again, that's one case where they decided they want their data to be used to train their own model, but they don't want to expose that to other users, which is fine, right? But we did detect different types of defect corrugation, all of that on Rails for that. We also worked with 1D data, just 1D signals from another rail company, and we were detecting anomalies and sorting out what was a true positive and what was a false positive. So where was it just the sensor going off for no reason, and where was repair really needed on the rail track. So I said I switched to the civil group about 2 years ago, and again we decided to focus on one specific domain for applying AI there, and the domain we chose to apply first was site design. So over the past 2 years, we've been working on that new generation of site design software. And there's a bunch of different places where we apply AI there. Actually, there's 3 main ones. The first one is that we built an assistant. That's the word that Ian used earlier, right? So leveraging the power of language models, we are able to assist the users with their site design, and we do a bunch of different things. So one of the things that we do is we can ingest documents. So for example, in the site design case, we ingest zoning regulation documents. So these can be very long PDFs, like 500 pages. They're written by lawyers, so it's not the kind of reading that you like to do before going to bed, or maybe it's actually a good idea to do it before going to bed because it will definitely put you to sleep. But yeah, it's something that's really cumbersome to go through. It takes a lot of time to locate the information, but LLMs, they are tireless, right? They can read through the whole thing in a matter of seconds, and they can answer questions about it, and they will provide you citations so that you can trust what they're saying, right? So that's been really helpful. You can also get information about your design through the Copilot, so you can ask questions, how many parkings do I have, for example, and then you can also act on the design itself and do simple commands that will evolve your design. So that's been pretty cool. I will show you a video on how it's performing. We also do optimization. So that's where generative design really starts to take place. So we can optimize the layout of a site, for example, decide where to place buildings, where to place parkings, so that we optimize the overall cost of the building. And with site design, grading is often one of the leading costs of the project. So we have earthwork optimization, where we can figure out really quickly how much it's going to cost to grade a site if we place a building there or if we place a parking there, making sure that we have appropriate drainage. So we can consider thousands of different options for a single site in tens of seconds. So instead of having the human go through the process of modeling different things, it's just the AI that looks at different options and will give back a bunch of suggestions. So when we talk about generative design, we don't think that AI is yet at the point where it can do a final design right out of the gate, right? So what it does is It looks at different options and will give you a bunch of suggestions, but ultimately it's the human that has to decide, because there's a ton of constraints that go into making the decisions for site design. And it's really hard to express all of those constraints for AI to understand, right? So if you are building commercial and you want your building to be visible from the street, then you can pick the design where the building was placed closest to the street, right? And you don't have to necessarily explain that or write rules that explain to the AI, yeah, I really want this thing, right? So that's the way we're approaching it, is just have, again, a collaboration between the human and the AI. And the final part, which we think is really valuable, is drawing production. So creating all of those drawings from the final design just takes a ton of time. You have to label them manually, all of that. So we are really automating that part as much as possible. We're using neural networks to place all of the annotation, take care of the white space management, and give you a look and feel that looks similar to what you would have done manually, but in seconds instead of hours, right? So yeah, just go through a quick video. So all of those AI features were added in our next generation of software, which we call OpenSite Plus, and many of those will also be applied to road and rail over the coming years. Again, we're starting from one domain. So as you start a project, you can import data from different sources. Again, that's one of the things that Bentley is really good it's really bringing data together from different sources. So you can bring terrain, you can bring building footprints, all of that. And that's where you can start to use the Copilot. So here, for example, I'm just asking the Copilot, can I build a hotel in the zoning that this site is located in? And the way the Copilot works is that it creates a plan first. So it's going to look at the zoning regulation document that I have uploaded and give an answer there. And again, I get an hyperlink where I can go look at the right page and make sure that the AI was right. Again, we can do site optimization. So we can run an optimization to look at different placement for the building and the parking. I can tie the building and parking together if I want, or let them go astray if needed. And I get a cost estimate for each of them, and then I can pick a design. And with the assistant, I can again ask questions about my design. So here I'm asking, how many parking spaces do I have? So I have 231. That's just an information that the AI is able to go. It can to give me back. It's able to interrogate the model, but I can also act on it. So I can ask it to change the parking angle to 60 degree, and then the assistant will just do it. It figures out all of the elements that it has to change, both the central islands and everything that's on the side of the parking, and it applies the change. And if, for example, the regulation would ask for different aisle width, when we do that change, it could also figure that out. But what's really cool is that we can use it also to check compliance. So we can ask, does the parking count meet the requirement? If I'm building a hotel with 200 rooms and 10,000 square foot of meeting space. And again, the AI will go back to the zoning regulation document, and it figures out that it needs to know in what zone we are. So it's asking for following information to be sure that it's giving you accurate answers. So we give the zone for the current project, and it will just break down the number of parkings and tell you if you're compliant or not. So that's the assistant part. When you're done with your design, you can also generate the sheets of your project. So it's basically as simple as placing a viewport and deciding what type of sheets you want, and using that create sheet option. And here we can quickly create, for example, a first sheet with dimensions. And what it will do is auto-generate all of the labels that need to be placed, and then the neural network will place them so that the labels don't overlap, so that the density of labels makes sense and that everything is readable, right? So that's pretty cool. You can configure the way you want your annotations to look. You can change the font or just the look of the annotations. And you can repeat that for another type of sheet for grading. So if you have a large project, it's basically just a repeat process. So you place your viewports. You can move them later and regenerate the sheet because it's so fast to do it. So having to edit a project, it becomes just much simpler. And you can also create different types of sheets. So here we have a grading sheet. There's a lot more labels, but still the white space management is handled automatically by the AI. So you get that look and feel. So right now, the way you configure the sheet is manual, but what we think is in the future, people will be able to just upload an old drawing of something that they've done, and we can copy the style of the labeling that they have done there and just repeat that, and automatically you get your sheets much, much faster. So that's about it. I know, Ian, I want to give you back the mic because we also have some other options for AI.
Yeah, just pause there. Thanks, Carl. So, I mean, really on the back end here, I wanted to come back to hypothetical. I mean, what we need to do is solve industry problems, and where there is a value add. Where are you expending time? Where could automation assist you? Now, with the site design market, they try to focus on that specifics for that market in terms of optimization of layouts, grading of car parks, and sort of the large language model in terms of running those queries. Just hypothetically here, I just threw out a couple of potential ideas, and there's lots of ideas, but what I really want to do is use these as a bit of a springboard into Q&A as regard to what are the problems you're facing and where do you see that automation would assist. Now, I mean, I put a couple up there in terms of clearance checking along a route, especially with overhead line structures and things like that, and sort of lateral and vertical clearances, signal sighting again, the visual compliance that needs to be built in and tested for as checking processes, but even potentially from a track redesign standpoint with regression analysis. Would there be value there in terms of automated regression for review based on historical processes and geometry layouts that you've got to automate some of those processes? So there's lots of possibilities that could be applied here from a hypothetical standpoint, but it really comes down to where is the value? What are the problems that you're facing that you see would benefit from a level of automation and assistance? And so with that, I'd like to sort of throw it out to Q&A. We can open the floor if people have got questions. Carl, do you just want to move on to 2 slides, actually, to the Q&A slide, and just leave it on that? Perfect, thank you. So David, with that, open for questions.
Yeah, thank you very much, Carl and Ian. So thanks, Ian. You pose a good question, I think, to open up. I mean, you gave a couple of examples around clearance and signal sighting as possible use cases in rail, but I wonder in the audience whether there are people would like to suggest other. Your challenge, I think, was what are the things that we're as an industry having problems with that might be suitable for to apply machine learning and AI. So I'm interested if anybody's got any suggestions there, and if they'd like to just turn their camera on and maybe make that suggestion. I'll just see what we've got. A question in the chat. Is this one? Pernell is here, Bentley colleague?
No, he's not. So it looks like he's asking.
Yeah, do you want to pick that one up?
Yeah, Carl, do you want to respond to that one?
I think it's really one of the strengths of the Copilot right now is its ability to look at regulations or large document. We're doing it also with CAD standards just for basic CAD design, right? Just to be sure that we are following guidelines or regulations. So in the site design world, I think it's maybe a little bit simpler than in rail because often your site is located in just one municipality, but actually we already have to work with sometimes conflicting information. So you can have regulation at the municipality level and then at the county level or state level, for example, that don't necessarily agree with each other. You can have planned urban developments that have different regulation as well, or you can have addendums to specific zoning regulations. So we have to be able to let the LLM understand that sometimes information in this document supersedes information from that other document, right? So it's starting to understand some of these complex relationships that are the kind of things that will, like, it's likely to lead to error even if humans are doing the design, right? So I guess I never thought of it, but if you have a rail project, obviously you're going to be in different local authorities, so you have a bunch of different documents that you need to consider, and it just seems like it would be a good fit for that kind of an assistant. Yeah, but maybe Pernod, do you wanna respond to that? What was the original intent of your question?
Okay, thanks, Carl. We'll let Pernell come back if he wants to. We've got a couple of hands up, so we'll go to the people who've got their hands up. First up is Stuart Corrie. Stuart, do you want to unmute yourself and come in with your question?
Thank you. There are multiple stories of large language models generating or hallucinating citations. And I see you're nodding.
Yes.
And have you built in safeguards for that? Was question number one.
Yeah,
great question. That I was going to ask that. Brilliant. So I think it's a great question.
Yeah, it's a great question. So we have we're lucky that we have an ability to let the user import documentation, right? And we ask the LLM to give us information that's grounded in those documents. So if the AI generates an hallucinated citation and it's not a link to the documents that we have imported, obviously we know that the answer is not good, right? So we have the ability.
You also need to check that that what the AI is outputting, it can output a sensible looking quote and a link, and the link can be completely valid, but it doesn't say what it's linked to.
Yeah. So we do. So that's one thing that we measure, right? So different LLMs are better at that, and they're really getting better at being grounded because a lot of people are using it for the specific purpose, and they're trained for that specific purpose. So we have, for example, we measure what we call groundedness, which is whether the answer of the LLM is actually representing the information that was in the supporting evidence, right? And that's something that models have gotten really good at. I mean, the bigger models, we're using GPT, for example, for most of our assistant work, and we get higher than 95% groundedness. So that's getting pretty good, but it's always something that we expect the user to double check if it's something that has legal implication, right?
That's an important point. You mentioned validation during your presentation. In the same way that we were all trained to do a basic check on a calculation that had been generated by a computer system. What seems to be unwritten here is that by getting the AI to help you, you've not abdicated your responsibility to, as an engineer, to sanity check the outcome. And do you think there's a risk that we forget that?
How do young people do that? How does someone coming into the industry without the experience?
That's such a good point, Stuart.
Which is where the next engineer is coming from.
Yeah.
Where is the PWI for AI?
Yeah. And it's the same as, bringing out the calculator to check the computer result. If you don't know how to do a simple shortcut fag packet calc to sanity check something, you're stuck.
Absolutely. So I mean, I would say with any checks that we're doing, they have to be based on engineering practice. And you've got to build that trust in that engineering practice, but you've still got to be able to do that engineering validation or computation or process, whatever it is, manually. Now, the idea with AI is that it provides automation for that. So as you develop that trust to hand over some of that responsibility in terms of the automation and churning through doing those lots of checks, you've still got to validate those. You've still got to be able to go in and do that. So you've got to have the manual tools available to do it.
I'm just thinking aloud. Sorry to interrupt you. I'm just thinking, like, do we not need to adopt a sort of traditional engineering practice here, in as much as AI is a productivity tool, in the same way that if you gave something to the upcoming, well, the junior in the office to in the old days to do a drawing, you'd have a checking process. So I think we need to be careful not to assume that we can, because we're using AI as a productivity tool, we can stop the checking process. Just conscious of, there's lots of good questions coming through. Can I go to Martin Davies, who's had his hand up and waiting patiently?
Yeah, thanks for that. So I had a question about monitoring, so sort of real-time monitoring. So we have a number of platforms where we have issues with PTI. I was wondering whether there'd be any AI applications that could monitor that to make sure that if someone's going down the gap or whatever, that's picked up.
So that's platform train interface for the underneath. So can I just say to people, can we avoid 3-letter acronyms so everybody's clear about what we're talking about? Yeah. So yeah, but absolutely great question. Yeah.
So what you're talking about there is some sort of IoT, Internet of Things. There you go. I spelled that one out. Sort of sensor readings feeding in and then automated monitoring. Is that what you're really talking about?
Yeah. So I mean, we have CCTV that covers the platform train interface, but we very occasionally have incidents where it's a busy platform, and whoever's watching the CCTV doesn't pick it up, the driver doesn't pick it up, and then a train leaves the platform potentially with a passenger in sort of harm's way. So it's whether there's an application where we could have something monitoring that's more reliable than a person, basically.
That's a good one. So that's real-time use of AI. Yeah.
Yeah. But also maybe like things like embankments where we have lots of data on that, on sort of monitoring them, and whether we could have an AI that's like monitoring what's going on and predicting when we need to go in and do something, because once it does happen, then usually there's an incident before we can react.
I mean, safety is obviously critical, but if you look at the camera systems that are going up on our roads all the time, the cameras are now sort of multitasking. They're not just looking at sort of potentially speeding, but they're looking at, are you using the mobile phone? Have you got your seatbelt on and things like that? So there's that level of checking, but that's not real time necessarily, but it's reporting and sort of tracking. There's a lot more that can be done. And it, as I say, it comes down to what are the real world problems that need to be solved and improved. And if that's a safety issue that potentially could be addressed by AI monitoring that and flagging that into an existing system to overcome the human error aspect of someone not necessarily picking up on a problem, absolutely, that's the sort of thing that AI potentially could assist in.
Okay. Yeah, no, it's great. I mean, we have a lot of platforms where the sort of geometry is fixed because that's how they built them, and so the risk can only be reduced to a certain degree, and then it's managing it. So that would be amazing to have that. Sort of.
So I know we've done in the past projects where we were detecting like people wearing helmet or not wearing helmet, and we were doing that real time. So there's definitely the capacity of doing it real time. In the case that you're talking about, I guess we would need to figure out the geometry for each camera first. Where does it become dangerous for someone to be standing? And I guess after that, it's fairly easy to have something running real time on it.
Okay. There's a question in the chat which might be a sort of an interim step towards that real time assessment, and Daniel Reddy's saying, could the next generation of AI allow drone survey corroboration of construction compliance real time to achieve automated assurance? So you gave the example of survey of an existing asset. So his idea is survey of a new built asset to compare with the drawings to self-assure in real time. Where is that something that you've done or something that you think could be done?
I think, yeah. So during the design phase, it's definitely one thing that we're trying to build is like real-time compliance, making sure that the design as it evolves, it stays compliant, right? So anything that right now we are answering with a reference to the zoning regulation document, we can make sure in the future that we are checking this constantly so that if you change your design at some point, it's not compliant anymore with one thing that we picked up on earlier, we can just raise a flag and tell the user, oh, your design is not compliant anymore. Or the other way around, if the regulation changes, you can just upload your new document and we will double check everything that was checked against the regulation and see if there's anything in the changes of the regulation that now make your project non-compliant. So during the design phase, that's something that we're working on. For construction, I don't think real time is necessarily possible just because of the time it takes to acquire the data, right? If you're doing a drone survey, it will take some time to process it. If you're doing LiDAR scans, it's the same thing. So I think I would probably see it like on a daily basis or a weekly basis, something that we check for compliance over time, but probably not real time. What do you think, Jan?
No, I'm sort of in agreement there. I think that construction side, I can see that real-time validation. You know, have you put the right thing in place? You know, it's kind of what level of construction. If it's scanning, you know, let's say you had an RF tag on a component that you were building in, well, potentially that could be tracked and that could get real time. So there may be sort of interim steps from a construction standpoint that could be made real time, but sort of you're just thinking from the ground up. You know, everything sits on the ground. Earthworks is really challenging to deal with. So that might present problems. But then we have to think about these things, and I say we as an industry, as you know, baby steps. Where does the value come in? And you know, if there's a need for that from a safety perspective, you know, to provide that assurance, then it's the sort of thing that can be pursued. But I do think there's a couple of comments further down that's sort of the generalized term AI, that reference the generalized term AI. And AI data science covers a whole range of disciplines, and optimization and automation. Just because we can automate something, does that mean it's AI? Well, it's kind of a it is kind of splitting hairs. It's a discipline, but it's not necessarily AI specifically. So I'm just going to say this. Karl might disagree with me, but I think the term AI is getting overused. I mean, we see it, you know, my fridge has got AI enabled or you know, whatever on it now. It's coming into areas where we think, really, is that AI? Is it just optimization of a process that we've done before? You know, so I think it is getting used or overused to a certain extent, and we do have to be careful with that, because not everything requires that higher level of the data science. So,
and to build on that, and reference back to your original dystopian future remark, I wonder whether we're the victims of marketing hype, if you like. And there's a risk of it going the wrong way, where AI. So at the moment, everybody's attaching AI to everything as a marketing ploy, frankly. That might actually be a hostage to fortune, because if AI, you know, were to start to, you know, if there was start to be, you know, bad press around AI, then actually it's unhelpful. And going back to what was said earlier, I mean, you know, some of the tools that we use in industry are automated design tools. They may not have been generated by, you know, machine learning, but the next generation probably will be. And so, yeah, I think we just need to be careful. I'm going to, I've got, there's lots of questions in the chat, but I'm going to give priority to anybody who wants to put their hand up and either ask a new question or ask the question that they've put in the chat. So is there anybody who'd like to put their hand up and offer a question? Okay, while you're all thinking about that, I'm going to pick one out from Robert Lacey, who's asking about have you applied a large language model to a company's suite of maintenance, construction, and/or design standards with an aim to provide an engineering assistance or check for holes and contradictions? I don't know whether you have, but I know quite a few people are doing that sort of thing. So, what are your thoughts about the opportunities there?
Yeah, so it's definitely one thing that we are doing, but it's always a matter of what are the tools available to check for those standards, right? So if we're doing CAD standards, for example, that's one thing where there's naming of different classes that needs to be enforced, and a lot of things that are easily checkable for us. So that's one place where we can pretty easily help the user and make sure that we are just managing the compliance to that standard. But if you have more complex standards to follow in your design, then it's a case by case basis, right? So the way that it works for us in the assistant is that everything gets stored in an iModel, and then the assistant can use queries to interrogate the iModel and get information from the model. So as long as the information is available there, or that the LLM can build the necessary information by applying mathematic formulas or something like that. Like if it has the dimensions of something, it can compute the surface, and then maybe there's a regulation that's linked to the surface of something, right? So the LLM has a set of tools that it can call, and then it can double check for whether the standards are enforced or not. But obviously, if we don't have access to what's the young modulus of a trust or something like that, then it's not possible. Like if we don't have a simulation engine, for example, to do structural analysis, then we cannot yet let the LLM handle that. So it's just a matter of I think it's one of the challenges that we have is making sure that the scope of what the LLM can check is clear to the user, because we don't want the user to rely on the LLM to check stuff that it just cannot check, right?
And the key thing there is obviously the citations, which is with the site implementation that we've done, providing that citation so you can go back to the source of the information and do that double check. Because again, it's about trust and what are you training it on. So yeah, the citation is absolutely critical.
Yeah. And I think that's yeah, go ahead.
Yeah, I was just going to say, I know from having experimented with this, that if you put a suite of documents into a walled garden AI and ask questions of it, it does exactly as you say. But I've seen it hallucinate and create absolutely fake citations. So you end up checking all the citations, and you do need to basically have some sound domain knowledge, I think, to be able to make best use of the material. Just as an aside, I'm going to bring Stuart Corrie in, who's put his hand up. But just as an aside, just to mention, I know, speaking of standards, I know RSSB are looking at how they can benefit from AI, because they have a vast catalogue of standards and guidance, etc. And I'm going to say what my vision for them is, and I don't know whether it's quite their vision, but my vision would be you could ask a large language model, I'm building XYZ, what do I need to know from the standards? And it wouldn't give you a list of 50 standards that you have to read from cover to cover. It would give you the cited individual clauses that you have to comply to. Anyway, Stuart, I'll bring you in now.
Thank you. I'd just like to slightly reword the previous question to point, is that what was previously being talked about was applying a large language model to a set of standards to see where the errors in the standards are, not against an actual thing. It's that the standards
to validate the
potentially, against themselves, purely for consistency.
Yeah.
Whether or not they're right is potentially a separate issue, but it's about, if you think about the size of NR and RSSB standards, you're trying to play with it all, and everything else, try and put all of them together in one go.
I think I'd sort of add to that as a parallel, if you think about it with legal documents, I don't know about anybody else, but if anybody's picked up a document that's come from a solicitor, if you're buying a house, getting divorced, doing whatever, creating a will, it's borderline unreadable. And if you're building up a contract, even more unreadable. So, but that sort of large language model is being used in legal systems to do that validation because it's so complex and wordy. So I think there are instances where it can be used and can be applied to sort of potentially identify contradictions in that document. But again, what are we looking for? Karl can talk more intelligently too. But I've certainly seen from a legal perspective that it is being used, generating those citations and actually identifying conflicts and using that in the process to actually improve that documentation. So, but Karl, if you want to.
Yeah, I think it's a great idea. Sorry for misreading the question. So one of the things that we're doing in site, which actually looks a little bit like that, is if you have like repeat business, let's say you're creating a Walmart in Chesterfield, and then you're creating a new Walmart in Springfield or something like that, right? And you get the zoning regulation documents from both. You can compare both documents and say, okay, what are the changes that are going to affect my design, right? And I think because right now, every time someone's doing site design, they're starting from scratch because they just don't know what are going to be the differences, and it's just too painful to go through the process. But I think with LLM, we're going to be able to do that. So we're doing it right now for changes or addendum, but we're also considering doing it for repeat business, like roundabouts in different cities or the same type of commercial site in different cities. So I think we'll learn from that. We're actually toying with that problem right now and seeing how effective it is. But I think it's the kind of approach that I would use if I were to compare or find discrepancies between different standards.
We're just coming up to past, so I'm going to bring it just as the last input. I'm going to bring in Joshua from RSSB, who's actually working on the project that I mentioned. So Joshua, you've got an elevator pitch here just to bring us up to speed with what you're doing. Sort of over to you.
It's really something I've just started a week ago. So seeing if there are any applications.
Well, that's a lifetime in AI, isn't it?
Maybe, yeah. So if you had any things that you would like from a user perspective that there may be some applications of an LLM2 regarding the standards, then that's something I can try to bring in.
Okay, thank you. Well, that's maybe an offline conversation, but I set out my vision, which is that we'd be able to ask this large language model, I'm building X, what do I need to know? What do I need to comply with? And preferably, to pick up the comment somebody else made, it wouldn't just be your standards. It would look into network. It would look into British standards. It would look into Network Rail standards. It would look into TSIs and NTSNs, and it just by asking that question, it would also do what somebody else was saying and flag up the contradictions and gaps potentially. I should probably draw it to a close. I should like to thank Ian and Karl. If you can imagine a virtual round of applause from the people we've got online, really insightful. And as somebody put in the chat just now, this is really exciting, very interesting to see how you're exploiting the technology. There's lots of little yellow clapping hands for you. So thank you very much. And it just occurred to me a minute or so ago, we were talking about legal documents. And I think it's been said that the legal profession is the one most at risk from the application of AI. Is that a problem? Discuss. Okay. So just to say, well, and I don't think the engineering profession is, because as we said, you need to apply a bit of engineering acumen to anything that comes out of, and I'm sure the legal eagles would say the same. Thank you once again, Ian and Karl. Fascinating discussion, lots to think about. And thank you to all of those who joined this afternoon. And I'm going to call it a wrap at that point. Thank you.
No worries. Thank you.
Thanks a lot.
Thanks, guys.